Hey guys, so I decided to do a series of videos on trig graphs. It'll be covering everything that you'll have to know up until grade 10. There'll be a three-part series. Part 1, which is what we're doing now, will be a overview of the trig graphs and as well as the basic structure. And then we're also going to do like the main terms that we kind of need to know, which is our period, our amplitude, and if you haven't heard it already, asymptotes. Okay, cool beans. So just bear in mind that there might be some things which I'll save kind of for the end. That's the end of part 2. That's being done only in IEB. So you guys can still listen to that if that's not what you're doing, but I have to cover it obviously. So if there's something that you don't need to know in your test, just pay attention. You don't have to pay too much attention, but just listen to it. Make sure you're getting it in your brain just for when you do it next year. At least you have it stored somewhere, so it's not the first time you're hearing it. Okay, cool. So let's get going. So we're going to look at 3 graphs. We're going to look at sine graph, cos, and tan. Okay, so our sine, so what it'll look like, we can use an f of x, we can use g of x, anything, right? We could use a y. We're going to do a sine graph, then we're going to look at our cos graph, and then we're going to look at, let's just call that a y, finally our tan graph. Okay, cool. So let's get going. Alright, so let's start with A. We're going to look at our sine graph. So y is equal to sine of theta. Okay, theta can also be anything, just a placeholder, right? It could be a beta, it could be alpha, could be x, could be y, could be whatever. It's just a variable. Okay, cool. So how we start off with our sine graph, we draw in our 2 axes. Okay, our x and our y axis. Okay, so if this is a test, make sure you labeling your axes, right? X and Y, make sure those arrows are displayed as how I've done it. Okay, what you want to do is you want to divide this into 4 equal parts. You don't have to measure them, right? Unless they've given you a graph paper, but just so that it's roughly the same. Okay, so a sine graph is going to look, alright, so there's 4 equal parts. We're going to 90, we label our degrees. 90, 180, 270 and 360. Okay, so our graph is going to look like this. It goes up to 90, down to 180, down to 270, and then up to 360. Okay, notice that it starts at 0. Okay, so as you'll see, when we get to this point here, our 360, if we were to extend our axis, right, and we carried on. So you notice that each time we went up by 90 degrees, right? So so 360 plus 90 will give me 450, and then this one will give me 540, and so on and so on. So a sine, cos, even our tan graphs, they never stop, they carry on, they keep repeating themselves over and over again. So what we have, we just carry on this graph. So you see it's going to go up again, same as how we did to 90, except now it's at 250, right? Then it's going to go down again, and it's going to carry on. So this graph's going to keep carrying on and keep carrying on. If we extended it the other way, it would carry on doing the same thing, except now it will be at minus 90 degrees, minus 180, minus, carry on forever. Okay, so, but for the purpose of not having to do it forever, we define something that's how often, or how long it takes, basically, how long it takes for our graph to kind of start repeating itself. So how many degrees it takes. So if we look here, it takes us from 0 to 360 degrees before that graph starts repeating itself. Alright, so we're going to introduce now one of those terms that I spoke about earlier, and that's our period. So our period of our graph is how long it takes for our graph to start repeating itself, or to complete one wave function. So if you look at this, it looks very much like a wave function. I don't know if you've seen it in physics. Otherwise, it just kind of looks like a wave. You know, back at primary school when you'd kind of draw waves like this of water. Yeah, so it's a wave function, and that means it repeats itself. So our period for our sine graph is 360 degrees. And remember what our period means is basically how long or how many degrees it takes to repeat itself, right? Or to complete one function, or to complete one wave function. Repeat itself. Okay, cool. So our period of our sine graph is 360 degrees. Okay, cool. Another thing we need to know is that, so you'll notice here that we've labeled our x-axis, but we haven't labeled our y. Alright, so we got to include our height and our depth. And what that is a 1 and a -1. Okay, so those numbers there, that's what we introduce. Our next term is our amplitude. Okay, so that's basically the amplitude is the height of our graph. So if we look here to there, that distance is our amplitude. Okay, A for amplitude. Okay, how we know it's a 1 is because there's a kind of invisible 1 in front of that y, in front of the sign. Just now, as you'll see in part 2, we'll start changing the value of A. So A can be a 2, right? Let's say we have 2 sine of theta. Then our amplitude will be 2 degrees, and we're going to know, 2, not degrees is on the x. It's going to be 2 and a -2, and our graph will look like that. Okay, but we'll get into that in more detail in part 2. So for now, you just need to know that our amplitude is what's in front of our trig graphs. Okay, so if it's a 1, it's a 1, 1 and -1. Okay, if it's a 2, it's a 2 and -2. If it's a half, it's a half and -1/2, and so on, every single number, right? So that's your amplitude. Your amplitude is our height, right? But more kind of mathematically worded is our coefficient. So the thing in front of sine, coefficient of sine, or the coefficient of cos, or the coefficient of tan. Okay, cool. So what we've done, we've introduced our period and our amplitude. Okay, so we're going to go over those with our cos graph. Okay, so if they ask for the amplitude of this graph, okay, our amplitude, it'll just be 1. Okay, you don't have to include -1 because we know it fluctuates between 1 and -1. So your answer is just 1. It's just whatever values in front of our sine or in front of our cos. If it was a -2, like I said, then it would be -2. Whatever's in front. Okay, so our amplitude of that graph is a 1. Okay, so we've got our period and we've got our amplitude. Alright, the last function, the last thing that we want to introduce is our asymptotes. But that is only in our tan graph, so we'll get to that after we've done our cos. Okay, so our cos graph looks exceptionally similar to our sine graph. Okay, so what we do, same as before, we draw in our 2 axes. Okay, for the sake of this, I'm just going to make this a bit longer so we can see it on both sides. Alright, so we divide it in 4 equal parts again. Okay, we put in our angles, which is 90 degrees, 180 degrees, 270, and 360. Okay, so each time, same as a sine, it's going to be a 90-degree interval. Okay, and remember to put arrows on your axes and label them, y and x. Okay, cool. So we're doing a cos. Our cos graph, unlike our sine graph, I'm actually just going to do it on these lines, it's a bit easier, doesn't start, so you see our sine graph starts at 0. Okay, started at kind of the origin of the axis. Our cos graph starts at our 1, so at our amplitude is where our cos starts. So it starts at 0 but in terms of the x, but 1 in terms of the y, and then we go down to 90. We go all the way down at 180, back at 270, and then up at 360. Okay, so that's, we'll notice now that we were here, now we've got back to that point. So that we know it's now completed itself, or now it's going to start repeating, it's completed a wave function. So we know that our period is 360. So it's the same as sine. Okay, so our period of our cos graph is the same as our period of a sine graph, being 360. If we had to carry this on in both directions, we would see that it just carries on forever. Okay, so you don't have to draw that in, you just have to draw the one section. Okay, so that's our period. Our amplitude, remember, our amplitude is the thing that's in front of our cos, and over there we have invisible 1. Okay, if they don't include it, we know it's a 1. Otherwise, if it's any other number, they're going to have to put it in front there. But for now, since we're just doing the basic structure, it's always going to be 1. So we know that my height goes to 1 and my depth goes to -1. Alright, cool. So we've got our amplitude. Remember, our amplitude is our height. Amplitude. Okay, so our amplitude of this graph is 1. Okay, remember, just the coefficient in front of our trig graph. Okay, cool beans. So you can see our cos graph and our sine graph look exceptionally similar. In fact, all it is that our sine graph has just been shown. So if you look here where I've drawn this A thing, our amplitude, if we go up to there and up to there, and if you block that off, you'll see that that's actually just a cos graph. So our cos graph and our sine graph is actually just our sine graph that's been shifted to the left by 90 units. So it's exceptionally similar. That's why our amplitudes and our periods are exactly the same, because it's a very, very similar graph. Okay, so we're going to look now at our tan. Okay, so our tan graph, y is equal to tan, and just for the sake of variety, I'm going to call this beta. Nothing changes, right? If it's theta, if it's beta, anything, it's exactly the same. All right, cool beans. So same as before, we draw in our two axes. Okay, so our tan graph is quite different, all right? But same as before, we divide it in equal spacings of 90 degrees. Okay, so here we're going to introduce our asymptotes. Okay, so first things first, you label your axes. Okay, x and y. We fill in our angles. 90 degrees, 180, 270, 360. Over here we have minus 90. Over here minus 180 degrees. Okay, great. So what an asymptote is where our graph can never touch. So it's kind of like a boundary line. Okay, so our asymptote. Okay, remember there's a P in there, everyone forgets the P. Okay, so asymptote is where the graph can never touch. Never touch. Okay, like a boundary line. Okay, it's a boundary. Can't touch it. We can get closer and closer for eternity, but it will never touch. Okay, cool. So where our asymptotes are is at minus 90, and then at positive 90, then over here at 270, and then we'd carry on. So you'd notice that the kind of gap between our two asymptotes is 180 degrees. Okay, so every 180 degrees, we're going to have another asymptote. Alright, so if we had to draw this for eternity, right, there'd be another 180 degrees and then be an asymptote down that boundary line, same as on the left-hand side. Okay, cool. So let's draw in our tan graph. Alright, so our tan graph looks, like I said, it looks very different, right? You probably, you're a math nerd when a tan graph gets you excited. Yeah, so anyway, so what we do is, alright, we kind of start here at negative infinity. So our graph's going to keep going all the way down, all the way to negative infinity. Okay, it's going to come up, it's going to kind of swerve like this, hits the origin, and then go all the way up to positive infinity. Okay, so that goes to negative infinity and positive infinity, and all the time it's getting closer and closer and closer to that asymptote. Okay, so just remember when you're drawing your graph, your tan graphs, remember to draw these arrows over here that I've just highlighted now in blue. Okay, those arrows there and there, you must draw them to show that that graph continues forever. Okay, cool. So we can do another one over here. So our graph goes down to negative infinity, goes through that point, and then up to positive infinity. Okay, so it takes a bit of kind of practice to get the graph looking reasonable, but don't stress. I mean, it doesn't have to be a work of art, you know. All right, cool. So this last one here, it's going to go down and come up. So if we had to continue, the graph would do that again. Okay, so but we've kind of run out of space. This graph from here would go, so it would normally come from down here in the bottom, and it would come up to here and then do that. Okay, so those two at the end are just kind of half of the graph. Okay, but anyway, so each one of these segments that are within our asymptotes, that's our period, that's our tan graph. So you'll notice that it keeps repeating itself over and over again. So our period for a tan graph is 180. Okay, not 360 like in the previous, it's 180 degrees. Okay, so it's different to the tan and cos graph. Okay, so the question you might be asking yourself now, because it is still an amplitude. See, like we had an amplitude on both of these graphs, right? So if you look at the tan graph, the amplitude is kind of like maybe a bit difficult to find because it goes up to positive infinity and negative infinity. And you'll never see a tan graph that has an infinity next to it. Okay, that doesn't even make sense. All right, because you can't times infinity by something. It doesn't, it's just infinity. Anyway, don't have to get into that now. All right, so what our amplitude is, so there's still a ghost 1 in front of this tan. Okay, so where that comes into play, so what our amplitude of tan is at 45 degrees here and at negative 45 degrees. So in other words, at halfway between our kind of asymptotes and our y-axis and our next asymptote, we're going to go up, touch that line and across there, and we're going to get a positive 1. So that's where that amplitude comes in. And this one we go down, and that gives us a negative 1. So instead of it now being the absolute height, like with the cos and the sine, we now have it at 45 degrees, we get our amplitude. All right, so our, that was in green, just want to keep the color scheme. Amplitude, so remember with tan, it's at positive and negative 45 degrees, right? And it's going to be 1. Okay, so we don't have to remember the same as before, we don't have to write 1 and negative 1. And just to be clear, that this amplitude will continue the whole way through. So over here we'll have 135, and it will go down, touch the graph, and across at negative 1. Over here it'll be 225, it'll go up, and then all the way across again to positive 1. And the same thing over here, it should touch there if I do this properly, and all the way across. That's, that would be 315, I think. Yeah, alright, so same as this with our amplitudes, they keep repeating themselves as the graph repeats themselves, so it doesn't change. Okay, so those initial conditions that we've spoken about, our period, our amplitude, and our asymptotes, if it applies our asymptotes, they continue throughout the graph. Okay, it doesn't change. Okay, so those are our 3 basic functions. Simple enough. Okay, so let's just do a quick summary. Alright, cool. So with our sine of theta, we have a graph that looks like this. Goes up, down, and there, right? We know that our amplitude is 1 and negative 1, and we know that our period is equal to 360 degrees. Okay, and remember these things, it starts at 0, goes up at 90, down at 180, all the way down at 270, and then back up at 360 degrees. Okay, cool. So now we have our cos graph. Y is equal to cos of, I'm just going to call it cos of x, right? It can be anything. So I'm just including variables now just so you're used to it. Okay, Our cos graph looks very similar, except it starts at 1, goes down at 90, goes all the way down at 180, goes back up to 270, and then starts again at 360. Alright, amplitude again is 1 and minus 1. And we put in our points. 90 over here, it would be 180. Here would be 270, and then there 360. Alright, and then finally we're going to have our tan graph. Oh, and just a little note on, like, just a hint or a helping sort of practice, I guess, is when you're drawing these graphs, what I recommend, and it'll really help you if you do this, is first divide your thing up into your axis up into your 4 quadrants, so you get your spacing. If you just kind of freehand it, you're always gonna probably end up with something that looks like it's gonna be skewed. Okay, it's not gonna be great. So just divide it up, it just helps you kind of guide a bit better. Alright, so oh sorry, I didn't include the period of our cos graph. Our period of our cos graph is 360 degrees. Okay, so tan, remember tan's the one that's different. Tan has asymptotes. Alright, those lines there are asymptotes. Asymptotes. Okay, remember those. Alright, without them your tan graph falls apart. Okay, we fill in our things. Remember it's minus 90, 90 degrees, 180, 270, 360. Okay, and our graph goes from negative infinity through the origin back up to positive infinity. Okay, we draw in our arrows. We go from negative infinity up to 180 and all the way to positive infinity. Okay, so once again, that's only half our graph. Alright, cool. We know our period is 180 because that's a different one, right? It's in between our two axes from negative 90 to 90. So we know that our period of our tan graph is equal to 180 degrees. Okay, each time it's 180, right? Cool. And our amplitude happens at 45 and negative 45. It's a little bit different. Okay, so there we're going to have negative 1, and over there we would have positive 1 at positive 45. Okay, great. So that is our basic graphs done. So we've got over our amplitude, our basic structure, and then in total we're all finished. So we got all of these covered. So that concludes part 1. Alright, so in the next section we're going to go over our standard form and how we're going to change things like our period, and we're going to change our amplitude, and we're going to see how they're actually going to start asking us proper questions. Okay, great. I hope this helps, and let me know any feedback whatsoever. Alright, cool beans.